Well, hello everybody, and welcome to this Frontiers in Science deep dive. Today, looking at how surgical roles may evolve and how predictive AI and robotics could improve patient outcomes while keeping things nice and safe for patients. I'm Gareth Mitchell, and I'm your friendly host for this session. And my goodness, we are an international gathering today as well. We have viewers from 75 countries joining us. So, greetings to you wherever in the world you are. Now, if you're new to Frontiers in Science, then this is our flagship multidisciplinary open access journal at Frontiers, and it's home to the very best peer-reviewed lead articles on transformational science. Now, we publish these articles across unique hubs with content for all kinds of audiences. So there'll be something for you, whether you're engaged with science or policy or society or all three. So far, we've published 34 hubs spanning 128 articles covering all kinds of cutting edge science. We've been cited over 1,500 times. We've had nearly 4.5 million views, and we often get picked up by the media because the content we produce is amazing. Now, today's deep dive focuses on this lead article, Evolving Surgical Teams in the Age of Artificial Intelligence and Robotics. Leading this excellent work is Professor Prokar Dasgupta. And it really is a thrill to host the article and its hub here on Frontiers in Science. So here's the scenario. Welcome to the operating room of the not too distant future, or operating theatre, as we say in the UK. So the scenario really is robotic surgical assistants working with the consultants and artificial intelligence monitoring thousands of data points, sifting and prioritizing the information that the medics and the machines need to keep the procedure on track. In other words, this isn't some kind of science fiction scenario where the only human being in the operating room is the patient and where the robots have eliminated all the medical staff. No, this is about technology assisting the humans and getting the best out of every medic. Every patient, of course, is different. So by definition, every procedure is different. All kinds of unpredictable things can happen involving split-second life or death decisions. And there's not an algorithm in the world that can handle all that better than a human doctor. Not now, not in the future, certainly not anytime soon. So this session really is about how we're going to let the machines into the operating room, but with doctors still very much in control. Robots will increasingly handle tasks like suturing or closing wounds or steering endoscopes, positioning cameras, and so on. And some of that is happening already. And AI will bring together data from multiple sensors and instruments in the theatre, more than a human could handle, while also putting together information from medical records and previous procedures, for instance. Today, we're discussing how that future scenario is going to happen and how it should happen. Who will benefit? What about healthcare systems in poorer parts of the world? How do we ensure that this kind of future will be evenly and fairly distributed? That's just one set of burning policy questions up for discussion. Then, of course, there's the paradox of training and supervision, because as we hand more tasks to the robots, how do we make sure that the humans supervising the bots have the skills to remain in charge? Many of you joining us today are building all of this, the vision language models, the embodied agents, the surgical co-pilots, autonomy frameworks, trial protocols, regulatory pathways. And it'd be all too predictable, really, just to spend our time talking about levels of autonomy. But instead, as with the lead article, we'll be focusing on the operating theatre as a kind of socio-technical system, asking how we reorganise complex surgical tasks across people and machines whilst maintaining the chain of authority that makes it all safe. The Viewpoint article on the Hub explores that. So stay with us as we bring together the authors of the lead article, the Viewpoint, and the editorial, alongside leaders in surgical robotics, AI, and clinical practice. We're not after consensus today, but just a better idea of where the genuine disagreements lie and what the priorities should be for research and regulation to bring about the best possible human in the loop future. So that's our task today, and we face it with enormous enthusiasm with the panel that we have and the experts that we've assembled. Right, but before we jump in, I just want to tell you very quickly a few bits and pieces, like we're going to show you around the hub, for instance. So this is the article hub. And alongside the lead article, we also have an editorial by Professor Lou Cavusi and Dr. Zorawar Singh at Northwell Health in the USA. Then we have a viewpoint article by Professor Russell Taylor from Johns Hopkins University. There's a policy outlook by Dr. Mikhail Koutinakis from the Robotic Global Surgical Society. And also on the hub is a video and a version of the lead article for kids, and that's in our Frontiers for Young Minds journal. I really love that journal. It's great. It doesn't matter what age you are, it's just a great explainer. And let's tell you about today's schedule as well. First, we're going to hear from the authors of the lead article, Professor Prokar Dasgupta and Doctors Alejandro Granados and Nicholas Raison. And then joining us for our panel discussion will be Professors Louis Cavusi and Russell Taylor. Right, so I think we should jump in. First, I'm absolutely delighted to welcome Professor Prokar Dasgupta, OBE, a world-leading clinician scientist and pioneer in robotic surgery. He's Professor of Surgery and Honorary Consultant Urological Surgeon at the London Clinic, and formerly of King's College London and Guy's Hospital. Appointed the UK's first Professor of Robotic Surgery and Neurological Innovation in 2009 at King's College, Prokar developed a pioneering technique for delivering botulinum toxin to bladder nerves using flexible cystoscopy, a procedure now used in millions of patients worldwide. His research focuses on surgical innovation, robotic and image-guided surgery, artificial intelligence in healthcare, and the immunology of prostate cancer. Prokar has an OBE, that's an honour bestowed by the British monarch. He's also a recipient of India's Padma Shri Award. He received the John Wickham Lifetime Achievement Award in robotic surgery in 2023. And in March this year, Prokar made headlines by performing the UK's first long-distance robotic operation. So there you go. You've heard all about him. Now let's meet him. Prokar, over to you.
Thank you so much. And hello, everyone. I'm really excited to be here, joining this international webinar. People from all over the world are going to enjoy this. But most exciting to me is that I am with two of my all-time heroes, Lou Cavusi and Russ Taylor. I have known Lou, would you believe it, for 30 years. When inspired by his work with the ESOP robot, I went all the way to visit him at Hopkins, and my life completely changed thereafter. The other two heroes of mine, who we were just celebrating at the Royal Society of Medicine last week, are the first robotic surgeon in the world, John Wickham, and the man who designed the Probot with him, Professor Brian Davis from Imperial College. And in the middle, you see an old BBC video which we dug out, where the Probot, which was built on a gantry and fixed to the operating table, is creating a channel in the middle of a benignly enlarged prostate gland, allowing the man to pee easier. But because Wickham is now gone, I went and asked Brian Davis just 2 weeks ago, saying, Brian, what algorithms did you train to make sure that the Probot did the right piece of work, i.e. followed the ultrasound scan and vaporized the middle of the prostate? And guess what? Let's put this to bed. Brian says to me, Prokar, in those days, there was no machine learning, not that we could use it. So it was entirely a piece of mechanical engineering, but this completely autonomous piece of engineering, which now sits in the Royal College of Surgeons, really has inspired an entire generation of robotic surgery and AI. This is where surgery is today. I started by doing open surgery, some 35 years ago. My specialty is radical prostatectomy for prostate cancer. For a few years, I tried to do laparoscopic radical prostatectomy. Lou Cavussi certainly tried to do that, extremely difficult. And then came the robot that you see on the right side, the Da Vinci system, which has ruled the robotics world for the last 25 years and has completely changed the way we practice surgery, not just for prostate cancer, but also for women's health, for bowel surgery, even operating through the mouth. But now, after a quarter of a century, we have at least 50, if not more, different intelligent machines coming to the market. So I put it to you that it is time to change. It is time to adopt to this technology, and the teams around us are changing because this is a growing and evolving market. So if you look at the international challenges we face, nearly 153 million unmet surgical procedures per year, 5 billion patients in the world who do not have access to decent surgery. And guess what? Surgical complications are the third most common cause of death worldwide. So just because the technology is evolving doesn't mean that we do not owe it to the patients and the public that we need to make access to surgery safe and access effective. We need to have that equity of healthcare that we are lacking in so many parts of the world today. So the teams, of course, have to evolve. When I started, it was a knife and fork. In the surgeon's hands, it was a scalpel, fine forceps. Then came laparoscopic surgery. Many of us used to do it very well. And I tell you that there are many very technically proficient laparoscopic surgeons in many parts of the world who can do surgery as well as you can do with robotics. But the problem is the effect on the surgeon. I don't think laparoscopy is ergonomically the right thing to do. It can affect your shoulders, your hands. So I think robotics really combines the best of open and laparoscopic surgery. In fact, some 15 years ago, one of my PhD students, now my colleague, Osama El Haj, looked at something called the Borg score. So this was measuring the fatigue of a surgeon, and the higher the score, the more fatigued the surgeon was. And laparoscopy had the highest Borg score, whereby open surgery and robotic surgery had the lowest such scores. So robotics combines the best of open and laparoscopy without making any big cuts. So good for patients, better for their recovery, and better for how we are going to perform surgery going forward. But then step forward another 25 years. In fact, let me tell you that what I'm about to describe is not new. The first operation to deal with this problem of inequity of healthcare was actually performed by Jacques Marescou, a famous French surgeon who used the Zeus robot and lines provided by French Telecom to operate from New York all the way to remove a gallbladder on a patient in Strasbourg. And this was published in Nature magazine in 2001. The following year, Cavussi and I performed the world's first robotics trial using a percutaneous access to the kidney robot between London and Hopkins, and showed that this robot was more accurate but slower than a human hand. And in those days, the lines that we were using were called ISDN lines, very slow, and we had 4 of these. Fast forward 25 years, where now we can perform telesurgery in any part of the world. Fiber optics, 5G, 6G has really changed the game. The Society for Robotic Surgery has led a consensus on this. These lines do not cost very much, about 50 euros. The latency is less than 130 milliseconds. These are highly secure, 99.9999% secure. 2 nines in front of the decimal, 4 nines afterwards. But amidst all this, please do not forget that the surgeon-patient relationship has to remain center stage. The first such randomized control trial was published in the British Medical Journal just a couple of months ago from China. And we had the great opportunity to write the editorial to it, which, if you're interested, is called Telesurgery 2.0, because it has returned 25 years later. And I think this has major benefits, major humanitarian benefits, because similar such surgeries, for example, have been performed all the way from Florida to Africa, in Angola, where the patients were unable to travel due to a cholera pandemic. Just a couple of months ago, after more than a year of planning, and this really was an example of teamwork, we performed the 3 first operations, all robotic-assisted radical prostatectomies with the 2MI system, which is telesurgery compatible. So these machines over the last 25 years have become telesurgery proficient. The Da Vinci system could not do that. And using lines which are called VPNs, these are like tunnels which connect the 2 sites. And over 2,400 kilometers, the time delay was only 60 milliseconds. In fact, just yesterday, the BBC, on something called Morning Live, covered this again with Ade Adipatan, who is a famous Paralympic gold medalist, who did an interview with me. And if you're interested, you can look it up on the BBC website. So London to Gibraltar, the first such in the UK, has also happened recently. About 5 years ago, during the pandemic, the UK Research and Innovation, which is part of the funding body in the UK, gave us a major grant called Trustworthy Autonomous Systems. This was led by a colleague from Southampton, just on the south coast of the UK. The press got hold of it, and they came to me saying, look, we have 7.5 million patients waiting in the UK. Why do you not program 7 robots so that you can do 7 times the work? And I said, look, although we are working on such things, this is pie in the sky. The data is not granular enough. It's not diverse enough. And this is not going to happen immediately. So you can see this horrified surgeon looking at machines doing the job completely autonomously while they have no control over it. So that is for discussion today. And I said, look, while I press a button, have coffee, and 7 robots do the job with no oversight is not what I think our patients want. And you would have heard of the Star robot in 2016, which can autonomously suture bowel in an animal model better than human beings. And then last year came the SRT-H robot from Hopkins. Professor Taylor will be able to tell you more about this. And when this came, the press got very, very excited. This is a fully autonomous system, which is called level 4 autonomy. It goes from level 0 to level 5. 0 is no autonomy. The higher the level, the more autonomous is the system. And I, at a patient-facing conference in December last year at the Royal Academy of Engineering, put it to patients as to if this machine can perform surgery on pig gallbladders with 100% accuracy, would they be willing to have this? And only a single hand went up. So the answer was not yet, will be part of trials, but we want a human in the loop. Yesterday, at London Tech Week in the AI Summit, which Nicholas and I attended, and you'll hear from Nicholas shortly, I asked the same question. And this time, that number had increased to 30%. So if you think the perspectives of patients and the public is not changing, then think again. It is changing rapidly, even over a 6-month period. We have established something called the Responsible AI UK, which is an international ecosystem, which, looking at the dissemination and adoption of AI, is busily putting AI champions in every hospital, not just in the UK, but internationally. And sadly, we have to work very hard to improve trust and trustworthiness in a responsible fashion, because a survey just last month shows that 18 to 24-year-olds in the UK, particularly ladies, trust AI the least. This is completely different in India, where during the Delhi summit just a couple of months ago, I realized that with a young population with average age of 26, they are really going after embracing and adopting artificial intelligence. So that's all I had to say, and I will hand you over to my dear friend and co-author Alejandro to take you through the rest of the proceedings.
All
Thank
right.
you.
Well, Prokar, thank you very much indeed. Very thought-provoking and so good to hear you, with the position and influence you have, saying that this really it's about the patient and the surgeon's relationship. That still matters, and that's not just some fluffy, nice thing to say. It leads to better clinical outcomes, whatever the automation. That is absolutely amazing. Thank you. Let's then meet our next speaker, Dr. Alejandro Granados, a lecturer in surgical data science at King's College London. Alejandro's research focuses on using artificial intelligence, data science, and advanced computational methods to improve surgical care. His work explores surgical phase and action recognition, multimodal data integration, prediction of intraoperative events, reduction of surgical complications, and patient-centered approaches to surgical decision-making. His research has resulted in 2 patents, a commercial prototype, a software tool used at the UK's National Hospital for Neurology and Neurosurgery, and has been featured at international art exhibitions, patient focus groups, and numerous public engagement activities. So, Alejandro, over to you. Can't wait to hear your presentation.
Thank you very much for the introduction. And everyone attending this deep dive related to our lead article, thank you so much for your time and for being here. Let's start with surgical AI. So something I would like to highlight is that data is fundamental to achieve safe and effective surgical AI. In the closed doors environment, characteristic of operating rooms where many things happen simultaneously, data can be related to 3 main different aspects. And these are shown in this figure. One of them is about the team, how they communicate, how they take decisions, how they interact, and possibly to monitor when they feel stressed or not, for instance. Data about the patient, the vital signals, and any observations captured via endoscopic cameras or real-time imaging about the anatomy the surgeons operate on. But data also can be about equipment, from robotic kinematics to scene reconstructions that allow for monitoring the entire room and tracking instruments and disposables. However, while AI has potential benefits to improve surgical practice, its impact is limited since data is typically scarce, not representative, it's modeled in isolation, and imagine it's mostly of successful cases only. To mention a few examples, I've organized these 6 different aspects. For instance, video cameras fitted into existing operating rooms can be used to train models looking into how surgeons interact. Physiological data captured from wearable sensors can be used to train models telling us whether members of the surgical team are stressed or not. And traditionally, endoscopic video is used to train models for surgical workflow understanding. On other aspects, real-time medical images can also be used as observations for autonomous surgery, whereas robotic kinematics could be used to allow trainees to reflect on their technical skills over time, while instrument tracking can be used to report metrics of instrument usage, for instance. In our lead article, we envision three main areas impacting the operating room. Data science will be a key enabler for personalized surgery, whereby data will be representative of entire patient journeys, linking pre-op and post-op information. Causality will naturally complement current randomized controlled trials on an ongoing basis by better mapping what intraoperative factors might lead to optimal patient outcomes, yet discovering interventional mechanisms tailored to the patient and to the experience of the surgical team. And copilots will support the entire surgical team through co-production and reasoning capabilities for better decision-making. However, the implications for the surgical team are diverse, from being able to empower all the members of the team by democratizing and tailoring data-driven information during surgery, and this depending on their role and their expertise. And I believe, and together with our co-authors, that this will open the door to better decision-making and upskilling. However, frictions include a reluctance of the surgical team for being recorded, trustworthiness of AI models based on evidence, and how best to interpret the outputs of AI models within the fast-paced environments that surgery could be. Second, today's surgical robotics found in the operating room are mostly assistive and fully controlled by humans, with only few cases executing planned trajectories. However, some of the challenges include space requirements, efficiency in positioning, and the time and experience needed to deploy them are some of these challenges for using them in the operating room. To name a few examples, for instance, robotic-assisted systems are becoming less invasive and more modular, with some examples bringing docking mechanisms for more precise interventions, such as those required for microsurgery, for instance. Another example relates to robotic systems used for emergency responses. Last, while some robotic devices adapt their interfaces to use existing medical devices, such as catheters and guide wires during endovascular interventions, others propose anchoring mechanisms to navigate through deformable anatomy, such as the colon. For this, we envision three key areas of development for surgical robotics. Robotic systems will assist the surgical team before, during, and after surgery, and this could range from patient preparation to self-cleaning technologies. However, to enable this, perception will be key for embodied agents assisting the surgical team. Last, the future of surgery will be impacted fully by autonomy, as we can see. Yet, the surgical team will remain always in the loop. For this, let me show you some examples. In this image, we map the potential robotic systems that are likely to be seen in the operating room, including handheld continuum robotics, emergency response units, fully coordinated robotic imaging and bed systems, for instance, as well as cleaning robots, to name only a few. Robotic systems with AI capabilities will perceive their environment more accurately in real time to better navigate within the operating room and interact with the surgical team. To illustrate this, in this slide here, we show how we reconstruct the scene from ceiling-mounted cameras available in the operating room into point clouds that can be further processed as observations by autonomous agents. Then, to illustrate autonomous robotics, we investigate here at King's how agents can be trained to navigate catheters and guide wires that are inserted into the vasculature of patients during mechanical thrombectomy for treating patients with stroke. Here, devices are inserted all the way from the femoral vessels and navigate to cerebral vasculature locations where blood flow has been affected. While this system has been designed for full autonomy, we are currently investigating how best human operators could interact with autonomous agents and what datasets can be created to allow for timely human interventions and support interpretability of human and agent intentions. Nonetheless, something that we are highlighting in this article is that human agency is fundamental for the efficient and safe deployment of autonomy. And this will be empowered by increasing levels of not only autonomy, but what we can highlight here is that increasing levels of human AI collaboration. Therefore, agentic AI design must bring value to the surgical team for delegation, assistance, and co-production, yet adapting to the needs and culture of the surgical team. What we foresee as implications for the surgical team are multifaceted, ranging from reshaping clinical roles to seeing new technical roles in the operating room. With higher levels of autonomy, surgeons are likely to act as supervisors, yet still decision makers throughout, while scrub nurses will coordinate, robotic scrub assistant, and circulated nurses oversee the overall logistics in the OR. Thank you very much.
Great. Thank you very much, Alejandro. And brilliant to hear you just ending on those all important implications for the surgical team and giving us, I think a really good insight into what autonomy means and what different levels of autonomy means, how some tasks are better suited to autonomy and vice versa than others. So thank you very much indeed for that. And of course, we'll hear more from Alejandro and all our speakers in the panel discussion that follows our presentations. Okay, so let's meet the final of these first three speakers who are just taking us through their presentations today. We're going to say a very big hello to Dr. Nicholas Raisin, clinical senior lecturer at King's College London and honorary consultant urological surgeon, King's College Hospital. A clinician scientist with expertise in surgical education and training, Nicholas's clinical practice focuses on functional, reconstructive, and neurourology, while his research focuses on improving surgical outcomes through innovations in education, in simulation, and skills development. Nicholas is particularly interested in non-technical skills, including decision-making, for instance, communication and teamwork in surgery. He was awarded the John Blandy Prize for his research on mental imagery in robotic surgery training, and he currently chairs the European Association of Urology Working Group on non-technical skills training. So over to you, Nicholas. Can't wait to hear what you have to say. Let's hear your presentation.
No, thank you very much. And thank you very much for the kind introduction. Now what I'd like to spend a few minutes talking about is thinking about some of the practical aspects about how we use these incredible tools that we've heard Professors Gupta and Alejandro tell us about, and how we ensure that we maintain patient safety. And as you heard right at the beginning of this presentation, really everything that we need to focus on and that critical aspect is patient safety. And so whilst it's certainly becoming, the horizons are becoming broader and broader about what we can achieve in terms of incorporating AI tools into clinical practice, we need to make sure that we're still delivering on that and ensuring that we still maintain the best possible care for our patients. And so what I'm going to be talking about is, first of all, using an example in practice and really starting to consider some of the aspects that we need to consider about when using these tools, what information we need to use as clinicians, what information, what data sets need to be provided in terms of developers, and how we can use these tools effectively. A lot of this work also plays into another role that I have as chair of the RAI Working Group on Health and Social Care that we heard Professor Des Gupta mention before. And really this is a key aspect of our work, is trying to drive forward this conversation and provide some guidance both in the UK and more widely abroad. And so in terms of exactly what we are thinking about in terms of regulation, what I'm going to be using is the example of a autonomous robot or partially autonomous robot, one of the few that is now clinically available and commercially available and is in clinical practice, both here in the UK and largely in America, known as aquablation. And so this robot is for, much like the Probot we heard about right at the beginning of this robot is for treating enlarged benign enlargement of the prostate, which causes bladder outflow problems. And the really unique aspect of this robot is that the surgeon at the moment provides a treatment map using an ultrasound image. However, the robot itself then determines and delivers that treatment. And as I say before, this is a conditionally autonomous system. So that means that it still relies on the surgeon to give it the go-ahead, but then the treatment itself is delivered entirely by the robot without any interference or guidance from the surgeon itself, obviously with a possibility of a stop function in the middle if things are going off record. And what is more, in what we're seeing in this robot now for the first time is also the development of an AI module. So an AI components are not, we are now moving beyond that conditional autonomy role to a level where we have an AI system which is able to provide that treatment map for the surgeons themselves and make a decision about where treatment is being delivered. And so this raises some very interesting, some very important questions about how we think about these new technologies and also the information we need to have and we need to demonstrate in order to ensure that these technologies can be used safely and effectively. In the case of this system itself, it was first regulated and given approval in the United States through the FDA, as can be seen there with the 510(k) authorization pathway. And really the essential of this pathway is that for medical devices, the initial approval requires demonstration that the system is safe and effective. However, then ongoing approval for further iterations of that system simply need to show that there is equality with previous systems. And so as a result of this, going forwards, as there's each iteration, then it can be that the lesser information is not required. And this also extends to the First Assist module. And so these have been approved on that same basis of showing predicate authorization rather than any of the essential authorizations themselves. And so obviously this raises then some very important questions about how we go about the accountability, validation, and fairness about using these systems themselves. So when thinking about regulation and authorization, what do we need to think about? What kind of aspects do we need to consider in terms of the oversight of these machines to ensure that we have the necessary information and availability? And as we're going to have increasing amounts of AI tools being brought into the clinical sphere and bringing into, particularly into robotic surgery, what we need to think about is how these approvals are being made. And currently, these can be considered across a number of different domains. So first of all, we need to be thinking about how, from a very traditional regulatory approach, we're going to be analyzing these new devices, ensuring that we have a good understanding about the risks involved with these. In the UK, we now have a framework known as AI as a medical device, which was brought in 2 years ago. And really, this provides more specific, focused regulatory requirements for AI tools themselves in order to show that these are relatively safe or effectively safe and can be approved into the clinical space. Alongside this, what we also need to start thinking about is not only is it safe, but also is it clinically effective, and also is it cost effective as well. And so here in the UK, we also have regulatory frameworks through NICE, which provides assessments about how exactly these aspects are, the clinical and cost effectiveness of these devices. And so in particular, we have something known as the Early Evidence Standards Framework and Early Value Assessments, where the initial assessments of these AI tools can be undertaken to see if these are making these standards. But alongside this as well, what we also need to think about is how we're bringing this innovative technology into clinical practice and that evaluation process within it. And historically, this has always been done through a point of multiple case studies and pilots. However, then we do get to a point where we have then very large numbers of pilot studies without ever getting that further evidence along it. And so now, again, we have some standards available through the IDEAL collaborative from Oxford University, whereby we can go through the different levels of evidence that's required. So from those first initial pilot studies up to larger randomized control studies and also post-market surveillance to ensure that we're continuing to gather and maintain the correct evidence to assure that the technology that we have is going to be doing what we want and being effective in that. And then finally, what we need to think about is actually about the more practical aspects of procurement. So how do we actually go about purchasing these devices for our hospitals, how can we ensure that we're getting the correct devices? And again, thinking about standards such as the digital technology assessment criteria, which we use here in the UK. And then finally, also thinking about data equity and bias. So thinking about the information that is behind the tools, where the data set's sitting, and ensuring that those data sets themselves have the necessary validity, they're reflective of the patients that we're treating, and these are, again, are effective. The other aspects that we need to be thinking about is also less on a standardized regulatory approach, but equally importantly about the ethical applications about these new tools. So as increasingly we're moving into a situation where we're going to have tools and surgical instruments, robotic instruments, increasingly making decisions in the operating room, we need to start thinking about how we're going to be achieving that decision-making process, how we have surgeons helping with those decisions, or indeed guiding and determining those decisions. And certainly at the moment, we're in a situation where very much the liability and the decision-making rests with the clinicians. But as we move to the future and we have increasingly complex systems, increasingly autonomous systems, whether that system is still going to be appropriate, as I say at the moment, from a legal point of view, the responsibility remains with the clinician. However, that also relies very much on the clinicians having the necessary evidence to be able to make correct clinical judgments. And so having the necessary evidence or understanding involves them having a good understanding of the models. They need to understand how models reach a decision that they're going to make and how the models choose certain treatment options, if that is the case may be. And we need to make sure that then the clinicians have that necessary information. And again, it's going to be in the not too distant future where if we have increasingly complex systems being involved in clinical care, are surgeons, are clinicians still able to make those decisions effectively? Do they have that correct level of understanding? Or do we need to look at a more broader assessment of liability, where we're looking at liability both across the system and with the clinician itself? And then finally, also, as we have this accelerating technology in the surgical sphere specifically, how can we maintain health equity? And going back to the initial example of the aquablation system, as I mentioned, so this is a system that is largely used in North America and to a lesser degree in the United Kingdom. However, as we see that they're developing AI modules in order to support this, the data they're getting from these AI modules is from North America and the UK. How can we be sure that this data is going to be applicable to other regions of the world, other populations, different levels of or different proportions of ethnicity, to ensure that patients remain that data remain generalizable to different populations, and that these populations aren't then left behind. And so, as I hope I have shown, there are quite a few different areas that we need to be considering, and certainly we need to be considering very carefully about how we're introducing this new technology safely into healthcare. We need to be thinking about patient trust and safety as well. And as Professor Dasgupta mentioned before, patient trust is, of course, vitally important. It's also something that is evolving and changing. However, what we need to ensure is that we're bringing our patients along and that they remain trusting in the clinicians that are treating them. And how we do that with autonomous systems, we still need to see. As we're finding already, there is an increasing degree of recognition that AI is going to be used in healthcare. But again, we need to make sure we do that safely. We need to make sure that the data we have is properly representative of the patients that we treat. We need to make sure that we're actively going to ensure that the data sets are fair and equitable. We need to make sure that we have the necessary regulatory governance. And again, as we've seen in the UK, we're starting to have these frameworks that are effectively able to determine whether tools are safe or not. The worry then is in other healthcare environments where there is less regulation, how then the clinicians and the healthcare providers can ensure that the tools they're using there are also appropriate for their patients. And again, with increasing complexity of tools, how can we ensure that the resources, indeed in many cases very limited, are going to be appropriately allocated to this? And likewise in terms of training of surgeons. So how can surgeons take on this new task of using these new autonomous systems effectively in terms of their care, and ensuring that we can open up this care to all our patients, not just those in the select high economic countries with a high technology. And so, as we've seen, there are implications for the whole surgical team. Certainly at the moment, the ultimate decisions rest with surgeons and they need to remain at the center of decision making, but exactly how this proceeds and how this interacts with increasingly complex systems we need to see. We also need to be empowered about how our roles are going to change as clinicians and ensure that we continue to have the necessary skills to be able to provide our patients safe care, even with these complex systems, and also making sure that we have the necessary safeguards in place to ensure that these systems can be implemented appropriately. And that requires both, as we've seen, regulatory requirements, and also more generally about the ethical and equity requirements for these systems themselves. And last of all, we need to make sure that we take our patients with us. They need to have a good understanding about what is happening, about how autonomous systems are being used in their care. We need to maintain trust, because really without that, we can't make any progress at all. And so, as we are seeing and as we've heard, there's a huge opportunity from these systems to really make a huge impact and revolutionize the care that we can deliver. However, this is only going to be possible, and we can only continue to do this if we're able to implement them safely and effectively. Thank you very much.
That's great. Thank you very much indeed, Nicholas. And very important, I suppose, just kind of précis of what we mean by regulation. And I find that incredibly reassuring what you were saying, that the regulation not only is possible, but we're seeing embryonic regulation now coming through. And I'm sure the big challenge that we're all aware of is making sure that the regulatory environment keeps up with the dizzying pace of technology as well. Nicholas. Thank you. So, of course, more from Nicholas in just a few moments as we open things out into our panel discussion. We're going to meet two more guests. Joining us now then is Professor Lou Cavusi, MD, the Waldman Gardner Distinguished Professor of Urology at the Donald and Barbara Zucker School of Medicine at Hofstra Northwell. And Lou is an internationally recognized leader in minimally invasive and robotic urological surgery, who's spent more than 3 decades advancing surgical innovation and patient care. His clinical and research interests focus on minimally invasive approaches to urologic diseases, including kidney cancer, renal stones, and urinary tract obstruction. Lou has also pioneered several landmark surgical techniques, including the first minimally invasive kidney operations for cancer treatment and kidney transplantation, and was part of the team that performed the very first laparoscopic prostatectomy for cancer. Also in our midst, we have Professor Russell Taylor, John C. Malone Professor of Computer Science at Johns Hopkins University. And Russell is a pioneer of medical robotics and computer integrated interventions. And he's really been at the forefront of developing technologies that enhance the precision, safety, and effectiveness of surgical and interventional procedures. For over 35 years, so more experience again, a lot of experience in the room today. And his research has focused on integrating robotics, computer science, imaging, and engineering to advance healthcare. His work has established the foundations of modern medical robotics and computer-assisted interventions, shaping a field that, as we've been hearing, really continues to transform clinical practice worldwide. Russell holds over 100 patents and has received numerous international honours, recognising his contributions to medical robotics, engineering, and innovation in healthcare. So there we are. We're Corate. We've met all 5 of you. Lou, let's come to you then. And you performed the first laparoscopic prostatectomy for cancer, as we heard there. You've pioneered minimally invasive kidney work, and that's just among so many other achievements. So I was kind of expecting your editorial with Zorawar Singh really to be quite celebratory. But instead, this is quite a cautious article, I found. And you warn especially about this thing called the expertise paradox. So tell me what you mean by that.
Well, before I start, first, thank you for having me. Secondly, more importantly, forget about Messi, forget Ronaldo, forget Pele. We got Russ Taylor here. All right. And and Russ is probably my most favorite scientist in the world. And I haven't seen Russ in person in a long time, but I'm just honored to be on the same panel with them. So to answer your question, I am very high on the future and high on what AI is going to do. The problem that I see right now is that we're getting a little overconfident in it. And the reason we're getting overconfident because we don't know what we don't know. So right now, the buzzword AI is based on hard data. It's all about data. So right now we look on this and I see you, Garrett. I know you're Garrett. I know Procar's Procar. I know Russ is Russ. In the operating room, while you're operating, there is shape-shifting going on. There is edema going in tissue. Tissue's behaving differently. And we, as a science, a surgical science, do not understand that well enough. And what we're basing what we do on is overcompensating. I'm gonna tender that we overcompensate in surgery because we don't know enough. Like, how long do we leave a catheter in or a stent in, right? We do based on sort of this, that, and the other thing. If we knew the actual data and we could use the data in AI, then for an individual patient, we can predict this. And my last comment on this, I'm going to misquote Nicholas, and I love Nicholas's presentation, but I don't know if I'm misquoting you, but the surgeons in this whole thing are the liability. We're the liability on multiple planes. We want to keep it, everyone wants to keep existing. That's biology, your cells, etc. You want to keep existing. And we think and going back to what I said, we think we're doing things the right way, but I think we're overcompensating. Now, AI will allow us to eventually do that, but there's a whole field of biology we still have to study. I call it tissue thermodynamics, how tissue actually behaves or changes over time that can create the data that the robots can do. And eventually there won't be anybody in the operating room. I believe there won't be, but initially we have to because we're not there yet.
Okay. Yeah, that's it's so important. No wonder you're so cautious. There's still a way to go. So Russ, let's bring you into this, and I mean, you've got a huge fan, obviously, in Lou and others.
Well,
Quite a
it's
few people-
mutual.
Quite a few of the other guests behind the scenes have been saying, Russ is taking part. So, so you kind of have come up with your own view on this, which brings in digital twins, and it relates really to what Lou was talking about there. This kind of representation between the bots and the human beings, isn't it? You know, how one represents the other, and how digital twin technology can help us around this. So just to fill that out for us.
Okay, I'd like to first make a brief comment about what was really good about that paper that we're talking about, which is they took a completely comprehensive view of surgical teams in the operating room. For 35 years, I've said that ultimately the robot isn't the robot, it's the room. And in fact, it's actually the entire intervention. Now, how does this relate to what you asked? Well, what we're really dealing with are human-machine partnerships, or actually three-way partnerships between people, technology, and information to improve patient care. And for the individual patient, what that means is you can somehow do something better than you could the old-fashioned way. It could be the intervention is safer, it could be more accurate, it could be something you can't do at all, it could be something which less invasive, whatever. But you're using information to help you do that. So down the line, and this is where the machine learning and the data comes in, we can begin to use that data to both right away, but also we can save it, and we know what the outcome was eventually, and we can improve our process with these machine learning methods. Now, if you're dealing with human machine partnerships, there are ultimately in all of this autonomy, there are two key questions. One is, can I tell the machine what I want the machine to be helping me with in a way I'm sure the machine will understand it and can do it, and equally be sure that the machine will not do what I don't want it to do. And that's where the safety comes in. And similarly, the machine needs to understand the task, the surgeon's intentions, and that can be very interactive. So you need a shared situational awareness. The machines and the surgeon need to understand what is going on now. It needs to understand intentions. And I've come to believe that just as in a way we process sensor information, what you need is basically a simulation of the patient, the task, the intervention that you can use in planning, but most importantly, you can keep updating it by using your sensing and using a lot of these very sophisticated vision and sensor fusion methods to keep that model up to date. So you have this awareness. Now, also on the action side, there are a lot of things you can do. Enforce the safety barrier is an obvious one. But in the end, the machine needs a capability that is somehow better than the surgeon to do some individual thing. And one of our other challenges, and I think this comes back to data, is we need ways to correlate changes in technical performance or speed, whatever, to clinical outcomes. And that's still a huge problem. So that's kind of a long-winded answer, but that's where these digital twins come in.
Yeah, absolutely. Yeah. And what could you say, used to make your mistakes on the digital twin, possibly, if I can put it very crudely?
Oh, well, yes, but you can also use these systems in planning and in developing new systems. Because the simulation capability. But I think the most important thing is actually the shared understanding in the operating room.
Yeah, indeed. Yeah, and as you say, correlating, technical advances with clinical outcomes as well, which is surprisingly difficult to do.
Yeah.
Great. Russ, thank you for that. So let's go back to
Right,
Procard.
can I jump on that then, what Russ said? So
Yeah.
therein lies the problem. Russ hit the nail on the head. And there can be great surgeons that keep doing the wrong thing over and over again. And we won't know it because we don't know the outcomes. And can I give a brief vignette? You can edit me
Sure.
out of it.
Yeah, just a brief one, because I'm going to go back to Procard in a minute. But,
So I do laparoscopic partials, and my bleeding rate, post-op bleeding rate that required embolization when I was in Baltimore was about 0.3%. All right. Suddenly I come to New York and my bleeding rate is 3%. Right. I'm doing the operation. I'm not in the residence. I'm not letting anybody do it. And I'm saying, did I get bad moving to New York from Baltimore? And what it turned out, I learned when a patient came in that I'd operated on Baltimore, but lived in Long Island. So I got to see him post-op. And I said, how are things going? Fine. He says, oh, I went to the hospital a month after the surgery, but I didn't want to bother you with. Right. So it dawned upon me that there is a lot of our big institutions will put up big publications, like in the US, the Mayo Clinics, the Hopkins, etc. The patients aren't local. They go back to their local doctors. And even though we call them, meaning our residents or fellows or medical students call them, they, number one, may not be giving them information because they don't want to insult us. And that's what they said. They didn't want to insult me.
Yeah.
So unless we get into the record, get the true information, we may not know who the best surgeons are to base all our robotics on.
Yeah. Yeah, it's such an important point. Okay, well, as promised, we'll go to Prokar, with whom the conversation began in this session. And Prokar, we've had this question. The goes like this: the lack of transparency in the operation of AI systems makes it exceedingly difficult to trace the root causes of errors and assign accountability to relevant parties. When an AI makes a mistake, asks this person, does responsibility lie with the hospital, the AI development company, or the algorithm itself? Prokar.
This is a tricky one because it varies from country to country. Uh, our regulator and the Patient Safety Agency in the UK are coming up with some guidance in the autumn of this year. We are looking forward to it. The reason I know is Nicholas and I and Alejandro, in fact, are part of this Responsible AI UK international ecosystem. So these folks get into the same room and speak to us all the time. And I think the correct answer, at least for the UK and for most countries, is a shared responsibility. So we cannot have a situation where a developer or industry says, look, the hospital got it, they installed it, it's the fault entirely lies with the health system, or you used it, I warned you, therefore it is your fault. So I think the short answer is responsibility will ultimately be shared. The law is differs from in different parts of the world, so the answer will be different for different parts of the world.
Okay, yeah, that's really helpful. And Alejandro, I wanted to put something to you, and Russ kind of raised this really. I mean, you're trying to kind of work out cause and effect basically, and like so you've got some kind of new robotic implementation, and it has a certain amount of some technical progress compared to the previous version. But how does that translate into clinical benefit? And this comes up into the article. It states that future AI co-pilots must better understand cause and effect, so not just correlations in data. So how do we get around that, in your view, Alejandro? Or can we?
Thank you, Gareth. Great question as well. It's very interesting because, as you all know, surgery, there's so many things happening. It's a very dynamic environment. And in my view, there's so many data points that are high dimensional, right? Now, understanding what happens there and not only correlated, but find those cause and effect relationships to what leads to poor or better patient outcomes, it's actually very challenging. Now, the question is exactly how do we get there, right? There's so much research in terms of how we can look into that in a more interpretable way, and that has been so far done mostly with machine learning, right? But here, because of the high dimensionality of the data, we're talking about deep learning, and I believe that's going to be changing substantially in the next following years. Now, the best way to get there, in my opinion, would be to start generating more interpretable features out from that cloud of data that we all know and have meaningful, and slowly start finding evidence that they are at least related to outcomes, right? And hopefully, by the time we start gathering more cases and more evidence and actually looking at different elements of interventions, then potentially we can start progressing in that ladder of causation. A lot of work to do here. Yeah.
Yeah. Okay. Who else wants to come in on that? It sounds like it's a very credible and doable to me, and I can't help thinking that machine learning is part of the solution here as well. It can be very good at sort of recognizing patterns, for instance. Any other comments from any more? Or we can go to Nicholas with a question that's coming from Mexico. Okay.
Well, I was just going to say on that point, as Alejandro was saying, and Professor Cabosi, sorry, before, the critical aspect of all of this is data and having enough of the information beforehand to be able to start to analyze and look at causality. And one of the reasons why we've not been able to do that yet is that we just don't have the data. So we need to know what is termed as the counterfactual. So we need to know what happens if we do something. We also need to know what happens if we don't do something. And then only on the basis of that, then can we start looking more closely into causality. And this all comes back to then trying to collect this high dimensional data, which there's a lot of it in the operating theatre, but we lose huge amounts of it. And the amount of data we collect in the operating room is tiny, and we need to really, I think that's where it's going to be the big push, is collecting more data in the first instance.
Yeah, I'd also like to just jump in very briefly. The most autonomous surgical robots are actually radiation therapy machines. And that's very close. Patient goes into the room, you push a button, and it does its thing. The planning and all this other partnering goes off on in the planning suite. But right now, what we do is we optimize dose patterns. And we've got a long line of research using data for that. What you'd really like, again, to do, though, is to optimize outcomes or predict complications. So I think that's, again, one of the things that we need to do, and probably ways of having federated learning or beyond single institutions will be very important here.
Yeah, and that's a great example, isn't it, of a kind of autonomous technology that's been around for ages, you know, so it's not an AI technology.
Well, RoboDoc was the same way.
Yeah,
the robot,
absolutely.
And this, in a way, you know, you get everything set up, you push a button, and the robot then takes over and does something where it can do it better than the physician.
Yeah, indeed, you know, and then it becomes a data question, or partly, you know, it's a lot of data.
Especially to correlate what you do to outcomes becomes very strongly, and the other is that you need the data often to recognize the situation.
Yeah, and I'm going to stay on data with Nicholas as well, because we had this from Delfino Vargas in Mexico. He talks about moves us on to bias in data, and it's obviously something you'll know a lot about, Nicholas, as will indeed the rest of the panel. So Nicholas Raison, says Delfino, talks about training data needing to be representative of the population served. This means that in other countries, like in Latin America, for instance, it's necessary to adapt the available data to serve a different population and to retrain the models using data from this population. And it's a population that, of course, will differ from a European one. And at a similar point, Nicholas comes from a viewer in China, asking pretty much the same thing. How do we prevent surgical AI, asks this person in China, from being trained mainly on data from wealthy countries and then underperforming for underrepresented patients? So get us over the data bias issue, if you can, Nicholas.
I mean, they're excellent questions, and I'm afraid that's quite an ask in terms of overcoming it. Well, the solution is relatively easy about collecting representative data from our patients. But obviously the execution of that is much more difficult. The main thing is, and I think the main aspect of this is just having awareness of it and being aware that this is going to be a critical aspect and something that we really need to focus on, and ensuring as far as possible that when these models are being trained, that we're having good data coming into those models, because essentially the models are only going to be as good as we've heard as the data that they're being trained upon. And already as I mentioned briefly in the talk, we do have guidelines. So there's something known as the Standing Together Guidelines from the UK AI Lab, with some work from the University of Birmingham, setting out some of the requirements for data sets, ensuring that they are generalizable. The other aspect of this is also having an oversight of what the data sets are. And then being aware that if there are limitations, that we need to be careful. It's not to say that tools are not going to be appropriate in other areas, but then you need to have extra care when using them, and being aware that potentially there is a greater room for error. And so if there is a case of automation, then perhaps that isn't appropriate in those cases, because obviously it's not going to be the case that every tool can be trained on an infinitely large or representative data set. But as much as we can, trying to have generalizable data, and then we're not being very clear about that, having that, highlighting that to clinicians so they can make the appropriate decision about whether to use these tools in their population or not.
Yeah. Okay. And what I'd like to move now is we're zooming through lots of different topics here, just because there have been so many brilliant questions from you, dear viewer, out there watching this webinar. And talk a little bit about training. And this might be one for you, Lou. Obviously, other panelists jump in if you want to as well. For instance, Hillary in the UK. Hello, Hillary, has been asking about how important it is to train clinicians in the computer sciences. And Adrian asked a kind of related question to about the danger of relying too much on AI, and then the inevitable problem, and I raised it in my introduction as well, this problem that, the whole idea is you're meant to have experienced medics overseeing these systems, but at the same time, these very technologies might be kind of undermining, or causing a deficit anyway, potentially, in clinicians' skills. That's a big one, isn't it? Lou, what do you think?
So, excellent questions. And I always say, don't let data get in the way of doing the right thing.
Yeah.
And what I mean by that is that there are other things that are difficult to quantitate by data when you make a patient decision. There are family issues, there are social issues, other things that the data isn't going to capture that can impact upon on what you end up recommending be done to the patient. The second thing on education, are you born a surgeon or are you made a surgeon? And I mentioned at the top of the discussion, there's some well-known individuals in sports. And what's odd to me is that, at least in the US, we are not screening people based on their innate abilities. You'll have a shorter learning curve to get to be the very best surgeon. Now, what this will do, what AI will do with the robots that already exist, is that it will even the playing field with those folks, because the most difficult part of the procedure will be done. As Russ mentioned with the orthopedic robots, it's the very difficult part is lining things up and boring a perfect hole. With Aquablate, making the perfect cavity. So it's going to even the playing field, and eventually you won't need people to actually physically do it. You'll need people to be able to figure out what needs to be done. Going back to my discussion, do we really know what needs to be done yet? And I think that there's going to be a renaissance in medical thinking, and AI is going to lead it. It's going to be the beginning of it. But we have to have rational exuberance about what's happening right now. We have to be rational about what it can do in the current world.
And I heard somebody nodding along there as well. I guess that was you, Russ, wasn't it?
Yeah,
I
no,
really agree. Yeah.
It's a wonderful insight.
Yeah. Okay.
The UK had something called the Topol Review. Eric Topol is a thinker, and the UK government scheduled this just before the pandemic, just trying to train the future workforce to adopt to the new way of practicing medicine, whether you're an anesthetist, a surgeon, an ambulance worker. So the UK set up a number of Topol fellows who are educated in that way, but a lot remains to be done because the world around us is changing. Medical training is changing. We are trying to bring in AI into the medical curriculum. Most medical schools, and this is not just here, but all over the world, do not yet have a standardized AI curriculum and skills training. So that needs to be brought in. So a lot of work to do.
Brokar, don't you think, why do you think they don't want to bring it in? And I'll give an example. One of our dermatologists, I mentioned AI in dermatology, says, oh, it'll never replace the dermatologist. I'm glad I'm not a dermatologist. Do you think that there's a conflict of interest in this in medical schools?
I don't, Lou, certainly not in King's, where the Dean of the Faculty of Life Sciences and Medicine is actively working towards bringing it in. And in fact, the guidance of how to do it was also came out as a JAMA paper in King's. So certainly there is no conflict of interest at our end. And even if there is that conflict in our mind, we are going to be overtaken. So I think we better rise up, adapt to the changing world rather than just hide our head in the sands.
Yeah,
Yeah.
I'd like to Go ahead.
Yeah, sorry, Russ, it's only because I haven't heard from Alejandro for a while. I'm just keen to bring him back in. But Russ, have you got a quick one? I don't want to cut across
Yeah,
you.
I
You're
was
an
just
eminent
going to
person, so
point out that, well, we use surgical simulators a lot in training, but we also, for instance, in some work we've done for 30 years on retinal surgery, where you sort of have a hand-over-hand robot that basically gives you tremor-free manipulation. And one of the things our surgeons often point out is that you can speed up training because you can begin to focus on some of the more cognitive and strategy aspects of retinal surgery, while this kind of in parallel training, the surgeons are learning how to control their hand tremor.
Yeah.
So the use of technology in initial phases of training is, I think, very useful. But yeah, I should.
Yeah. Okay. Thank you, Russ.
I don't want to hijack it. So.
Not in any way. No, we're all interested to hear what you have to say. But Alejandro, I just wanted to ask you this. It's something that occurred to me as I was reading the lead article, which is that research shows that in some cases combinations of humans and AI can actually perform worse than either the human or the AI working entirely alone. Is that something that troubles you, Alejandro? Is that even true?
It's in my opinion, it was such a fascinating thing to read about, and literally, I think it comes at a timely moment because we can question ourselves for what really we are doing, right? When you look at those results, actually, what you realize is that most of the AI models that have been designed are not necessarily for decision making, right? And this is the aspect that score the least when both humans and AI wanted to work together. And I'm saying this because potentially what we are seeing is AI tools that can assist and can generate content and would make it potentially more efficient, right? But if we really want to bring AI into the equation to work together, there's a lot we need to do in terms of decision making. Joy.
Okay, and folks, we just got about 5 minutes left to go before we begin to wrap things up. So I'm going to cram these questions from the listeners and viewers as much as I can in. Ankit Joshi, this is a fascinating question, asks, how close are we to AI systems that can make context-aware interoperative judgments in unexpected situations mid-surgery, such as difficult tissue planes, bleeding, inflammation, or distorted anatomy? So what happens when things are unexpected, folks, or God forbid if things go wrong? I'd have thought that's when you really want the human being in the room. Who wants to take that one?
I can take it. I answered Ankit briefly. Ankit, we can do this in the lab today. But I keep telling Alejandro, I want real-time guidance, my man, to tell me where are the no-go areas. And that is not yet ready for real time. So we are not yet ready. Mixed reality can help tell you where the dangerous structures are, but real-time guidance, I'm not aware of a system that is active clinically. I think we are a few years away.
Okay, yeah. Do we all agree on that? Nobody's going to
Yep.
Yeah, I
dissent
think in
there?
between what is also coming down the pike is the whole remote assistance, remote surgery. So if I'm doing a case and one of the world's experts is in the UK, Prokar, who's one of the world's experts, I say I can beam him into the OR and he can do that. So it's going to be layered. All this is layered. And it's a beautiful time to live in medicine and live in surgery as we're beginning to see this, and we're blessed enough to impact upon it in a little way if we can do that.
Yeah.
Yeah.
Okay.
I think that, again, there's a perceptual issue here where sometimes these twin simulations can be useful here. If our sensors are showing us something that is very different than what the simulation predicted, at least then the robot can say, hey, surgeon, I'm out of my depth here. This is out of distribution.
Yeah. Okay. Right. Now, I think we're literally just into the last 5 minutes or so. I think at this stage, I'm going to get each of you to make your final comment, and I'm looking for no more than a minute from each. Just kind of giving us your overview. Really, what's the big, most important thing you want people to take away from this session, especially if it's something you've not said already, because that lousy chair didn't ask you the right question. So, Russ, seeing as you're on mic already, what's your final thought? Just a minute or so, no more.
Okay, well, first, again, it takes a village. I think as we go forward, we really need to think about roles for assisting the entire team. And I would take that beyond the actual tissue manipulation surgery to include rehabilitation, follow-up, and so forth. And I think I think a lot of the problems are perception. And that's where this learning can come in. Okay, there's my
that was very tight. Russ, appreciate it. Lovely. So Lou, pick that up for us as well. What's the big most important thing I should have asked you or you haven't said so far?
So, in talking about the ethics, I think it's unethical not to do the best thing for your patient. And as AI evolves as the best thing to do for your patient, that's the most ethical thing to do. Number two, when they say it's not about the money, it's always about the money. And I think it's important as people are thinking about this, to really see how this will, on an economic standpoint, help society, help the country, help the individuals, because that's what's going to drive this. It's the economic feasibility of this.
Okay, Dasgupta, let's come to you. What's the big most important thing we all need to take away?
So, for me, it's the future of work. And for the audience, if they're interested, there's a Nobel laureate who has written a review on this called the Pissarides Review. You can download it, have a look at it. But here is my message to you. Do not be afraid of the future of work because AI is not going to steal your work. What will steal your work, if you're not careful, are the people who are adopting AI. So please adapt to the changing world around you, particularly if you're part of a surgical team, as I am.
Okay, but your job is safe, but don't ignore the people around you. Yeah, and it is. I mean, surgery is such a team effort, isn't it? Alejandro, what would you like everyone to take away from this discussion?
Thank you. I would resonate along the lines of Professor Liu mentioned. We're at a turning point of revolutionizing surgery. And it's fascinating to be today working on that. And I would just invite the entire scientific community interested in this area to talk together, ask the right questions, and move forward together. Thank you.
Yeah, okay. And as that comes about then, Alejandro, what keeps you up at night? What's your biggest worry around all this, if you've not said it already?
Oh, there's so many things.
Where do we start? Okay.
Yes. No,
Yeah.
so many opportunities. That's what I can say.
Yeah.
And it's fascinating to see a lot of work in the community, but I think we need to stick together and ask the right questions. I think that's my main message here.
Asking the right questions. Nicholas, I'm going to ask the right question here, I hope. What's the big important thing you want people to take away?
Well, I think the main thing to say is that looking back, potentially talk about regulation and rules can be overly negative. And I think, as Alejandro and everyone was saying before, it's incredibly important that we do use the AI to its max. I think there's a huge danger in standing still and not doing it. So healthcare is in trouble. We have too many people, too little money, too little doctors. In order to continue and maintain the standards we have at the moment, one of the few ways of doing it is using tools like AI. So I think there's a huge danger in standing still. We need to keep moving forwards, obviously doing it safely, but keep pushing forwards. It's going to be important.
Yeah. And of course, it's so important what you said there about, yes, we need to move forward, but we need to do this safely. And you did kind of preempt my inevitable question is like, yes, but if we move fast and break too many things, that's not a good place to be in the operating room of all places then. So not that this is going to be a particularly easy, quick answer in our final seconds, but how do you do it safely? Just making sure the right people in the room having the discussions?
Yeah, as we're doing preparing beforehand? This is something you do before you do it, not afterwards. It's not an afterthought, it's a critical aspect of it. So when you're doing it, this is really about changing the whole organization. This is not about just bringing in a quick technology.
Okay, lovely. Well, there we will leave it. So thank you very much to you, Nicholas. And of course, we've also heard in this session from Alejandro, Procar, Russ, and Lou. And we've heard from you, dear audience. You've asked some amazing questions. And I'm so sorry if we didn't get, well, I know we didn't get to fit them all in, but we did our best, I can assure you. So huge thanks to everybody for joining us and having so much to say. So there you go. That's it from me, Gareth Mitchell, and our guests and the entire brilliant team at Frontiers. Thank you, experts, and thank you for watching. Take care, everybody. See you next time. Bye-bye.